Hello. So for today for science, we are going to talk about electricity. So go on and get a piece of paper and start taking notes on electricity today. So we're going to talk about it this week and next week. This week we're going to focus on conductors and insulators, circuits, and static electricity. So electricity is the continuous flow continuous flow. Oh, I'm just taking pictures of what. Okay, I think I'm settled now. Continuous flow of electrons So electricity is a continuous flow of electrons, and this is the electric current. Okay? The pathway taken by an electric current is a circuit. Okay? So there are two main circuits, and then there are a couple other circuits. Okay? So I'm going to get it. I need new pens. Santa Claus is going to have to bring me some new pens for Christmas because I don't know where they're all going. All right, so we have closed circuit. Okay. And that is when all movement of, so that's when all the electricity is flowing. This is lights on. Okay. So right now, on my projector, the circuit is closed, which means there are no gaps. So if you take your finger and do this, make a circle, that means that there are no gaps, okay? It is closed. That means the electrical current can travel, all right? Lights are on. But then if you have an open circuit, it's the opposite. It is a gap in flowing electricity. So that is when lights are off. So if you think about, my husband and I have worked really hard to get my house decorated for Christmas, and I always unplug everything, of course, before we go to bed. So when I unplug a strand of Christmas lights, that is opening the circuit. That is preventing a flow of electricity, because electricity has to have a starting and, it has to go in a flow. And if you create a gap, there's nowhere for that electricity to go. Okay. So this is open. Okay. The electricity is not going to be on. There's no way it can be on. This is closed. Okay. So when it's closed, that means the lights are on. Right now, on my projector, the lights are on. Right now, they're off. I have opened the circuit, creating a gap where the electricity cannot flow. And now they're on again. So I'm going to try to draw a picture. So if I draw a picture of, I should have done it with, all right, let's do here. Closed circuit. and then open. Okay. My husband is smoking dinner today, and it is filling up the house with, like, you can smell, it smells like a campfire. All right, so if I have the battery, we'll just say a battery. And then, please don't laugh at my light bulb. That's awful. Okay, that's my light bulb. All right, if I've got a wire, okay, and it's connected, okay, this is open, light on. If I have a closed circuit, I think I just said that backwards. Closed circuit is when the lights are on. Okay, there's no gap. An open circuit is when the lights are off. They have a gap. I was more paranoid about my light bulb. So there could be one side that connects, but if it doesn't go all the way, it doesn't connect. It's not going to have light on. Okay? Now, talking about open and closed, there are a couple other circuits that we could talk about. There is a series circuit. Now, if you have a series circuit, I am so sorry, the smoke is killing me. A series circuit, you can have a closed series circuit or an open series circuit. And what that means is a series is like a strand of Christmas lights, where you have one power source, and then you have maybe, why can I not draw a light bulb? Like, what is my brain stops? Okay. You can have all these lined up, but if there is a break in it, that would be a open circuit. But if it loops, if it's all connected, it would be closed. That means that the lights can be on. So what that means is that if it's a series circuit, if this light burns out, then it can't close, okay? Because there would not be a way that there could be continuous flow of electricity. So if one light burns out, it's not going to be able to turn on. So that most of the Christmas lights, well, they used to be series circuits. Now they've changed it to where there's a couple different wires. If you look at your Christmas lights, there are it's more than just one wire. So if it's more of now, it's a parallel circuit. Now, but those old-timey Christmas lights, they usually just have one wire and they're a series circuit. Okay, one light burns out. So if one light burns out, it's not going to light up. But if you have a parallel circuit, which if you think about your classroom, I know Chrysler has parallel circuits where there's more than one way that the electricity can go. So if one light bulb burns out, it's not going to cause all the lights not to come on. It'll still have the ability to light up. Okay, so I'm just going to draw. That is awful. I don't know why I can't draw a light bulb. I've been doing these notes for years. Oh, that's better. Okay, so if this light bulb burnt out, so the electricity can't flow this way, but it can still get to these two. And the same way with this one. If this one burns out, it's still going to be able to light up. So parallel circuit just means that there are two or more pathways for electricity. Oops. I apologize, y'all. I don't know what is my problem today. Pathways for electricity. Okay. So you can have a closed parallel circuit, meaning that it's on, but there's different pathways for it. And you can have an open, because if you turn off the parallel circuit altogether, it's going to be open. Okay. All right, let's move on. So if you're talking about electricity that is a flow, you have to have something for electricity to be conducted or to be insulated. So, and that's what you're going to talk about today with a couple activities that we're going to do with Virtual Virginia. Okay. So conductors and insulators, if you think of those Christmas lights, what's around those wires? Well, it's rubber, because rubber is the best insulator, meaning that it does not conduct electricity. So you can pick up those Christmas lights without being electrocuted because they are covered in rubber. So a conductor helps electricity flow. And these are going to be things like metal, which is like wire, and water. They're going to conduct electricity. But then insulators stop the flow. Okay. And these are things like rubber, like I said, that's on the wires, plastic, and wood. All right. I'm also put wire. That's metal, but I'm going to put wire there. All right, and then the last thing we're going to talk about this week is static electricity. So it's a little bit different. Chrysler used to have all carpet. And in the wintertime, I'll tell y'all what, I would shock myself on the board every time I would get up. So, like when the winter, you have more static electricity. And I would, when I'd get up from my chair when I was teaching and get up to the board, I guess when I would rub my feet on the carpet, it would create the static electricity. And then when I would touch the board, I swear I would always electrocute myself. Not really electrocute myself, you know what I mean? All right, so static electricity is when you can rub materials together. And that would be like carpet and a balloon. You can rub that on your hair. And then a balloon on hair. Lightning is a discharge of static electricity. Okay. All right. So the next time we take notes, we will talk about energy, we probably don't talk about, we've already started talking about energy, but magnetic fields and the historical contributions to electricity. Because there are three fellas that we have to remember when we talk about electricity. All right, so make sure you have taken these notes, and then you will have a few activities to do, and I'll see you on the flip side.